In 2.3, we are solving absolute value inequalities. So what we're doing mathematically is no different than what we did with equations last time. The only difference is that instead of the equal signs, they're going to have what in them? They're going to have inequalities. What are our inequality symbols?
This sign, this sign, this sign.
Okay, hold on. Let's just review, make sure we know. What sign is this one? That's a greater than. Okay, easiest way to tell ever, hold up your left hand. Hold up your left hand.
Less than.
Your left hand makes a less than symbol. Your left hand is never going to change. This one is always your left hand. Unless you lost a hand and someone like donated a hand to you and you were able to like put their right hand on your left hand. Okay? Otherwise, your left hand is always going to make a less than symbol. Yes, John. Okay. So that's a greater than, and then this one is
Greater than or equal to.
okay, and then and okay. It's important that you identify that you can identify the symbols. Like, yes, I get that in elementary school you learn that the alligator eats the bigger number. That concept is not a terrible concept, but it's not going to help you with inequalities. If you ever tell me, well, the alligator is eating the 5, that tells me nothing. I need words like math words. Less than, greater than, less than or equal to, greater than or equal to. Yeah. Okay.
What page?
We are on page 91. Okay? All right, so we're going to look at problem A. I know it gives us some explanations. I'm going to ignore the what it's giving us, and we're going to talk about how we would actually solve this algebraically. So if I had this problem, the absolute value of x plus 2 is less than 5. Okay, well, think about solving this if it was an equation. If this was an absolute value equation, what we just finished doing, what would you do with that plus 2? You'd subtract 2. And you would end up with the absolute value of x has to be less than 3. Okay? So again, going back to if this was an equal sign, what would you do at this point?
You would change the 3 to a negative and positive.
Okay, so you would rewrite it as 2 separate problems. You would write it 1 as the absolute value of x, and you would say is less than 3 because that's what it was before. And then the other one we would do is the absolute value of x, and instead of positive 3, it would be negative 3. So because we switched that sign from a positive 3 to a negative 3, what else do you think we do?
Switch the sign.
We switch the inequality sign. So we would say that our answer would be the absolute value of x. I'm sorry, hold on. Let me erase something. There's no longer absolute value symbols here. My bad. Sorry, when I split it into 2 problems, that takes care of my absolute value symbols. Okay? When we split it into 2 problems, that takes care of my absolute value symbols. So we're saying that x has to be less than 3, but x has to be greater than negative 3. How else could you say that? That x has to be less than 3 and x has to be greater than negative 3.
Negative 3 is...
3 is greater than x, which is less than negative 3. Like, write it in a big line.
Okay.
Like, so it would be the 3 plus the 3 first,
Okay.
then a greater sign, and then x, and then a less than sign, and then negative 3.
Okay. Any other thoughts?
Like, do the range.
Great.
Negative 3 is less than x, which is...
I got it.
I mean, that looks better.
How about this one? Negative 3 is less than x, which is less than 3.
Is my answer wrong?
Your answer's not wrong, but the way that is written is not mathematically correct. Like, your theory is not wrong. Let me say that, okay? But when we say, like, when we write inequalities, like, we have to write them in a way that makes sense. And we always start with the smallest, going back to domain and range. Like, when we wrote domain and range, we always started with the smallest number, whatever the smallest number was. So the same thing is true. So what we're saying, and to give you a graph of this, because sometimes seeing it graphically helps, is we're saying that it said x had to be less than positive 3. Well, here's positive 3, so it'd be everything to the left of that. But then we also said that x had to be greater than negative 3, so it's everything to the right of that, which really means that it's everything in between, in the middle of negative 3 and positive 3. but not negative 3 or positive 3. Why did I draw open circles there?
Because if you fill them in, that's less than or equal to.
Yes, when you have filled in circles, that is less than or equal to. Okay? And literally, this is what we're doing today. Okay? So that's pretty much all it is. I know, I'm such a terrible person.
How do you even grab that?
We'll figure it out. Okay, number 6. Number 6. You have the absolute value. I'm on page 93. You have the absolute value of x plus 1 minus 4 is less than or equal to negative 2. Well, if I'm going to solve this, just like I was solving an equation, what do you do first? Okay? Because your goal, you're trying to do what? You're trying to get x isolated, but before you can do that, you have to get the absolute value symbol isolated. So the absolute value of x plus 1 is less than or equal to positive 2. So the absolute value of x plus 1 is less than or equal to positive 2. Okay, so I have the absolute value symbol isolated. Now I need to do what? Split it into 2 equations or 2 inequalities. So the first one is going to be what? It'll still be less than or equal to 2. Yeah. And then the second one would be, it'd be greater than or equal to negative 2. So there's our 2 problems. Okay, how do I solve this first one? X plus 1 is less than or equal to 2. Minus 1, and you get x is less than or equal to 1. And then how do you solve the second one? Minus 1, so x would be greater than or equal to, okay. And then if I want to graph that on a number line, here's negative 3, negative 2, negative 1, 0, and 1. I'll go ahead and put negative 4 and positive 2 on there. Okay, so if I'm graphing it on a number line, where is one of my points going? At positive 1, is it open or closed? Closed. It is going to be a closed one. And how do we know that? Because it's equal to. And if it's x is less than or equal to 1, which way am I going? I want x's to the left or to the right? To the left, okay. And then x is greater than or equal to negative 3 means I'm going to have a closed point at negative 3, and I want to go to the right. So that means it's going to be everything in between negative 3 and 1.
How do you know negative 3 is close to 1?
Because it said x's that are greater, and like thinking on a number line, things that are greater are things to the right. Like negative 2, negative 1, 0, all the positives are greater than negative 3. With inequalities, what is the one thing that makes them different from equations when we're solving that we have to remember? Nope, when you're solving. Haley? Yes, when do you flip the sign? If you divide by something negative. So that's the important thing to remember. That's literally the only thing that like makes these different. Yes, ma'am. Okay, page 95. I have 3 times the absolute value of x minus 7 is greater than or equal to 9. Okay, so if I'm going to solve this, what do I do first? Divide by 3, because again, we don't need to distribute those things in. It's going to throw off our absolute value. I'll be honest, if your number is positive, distributing it in doesn't change anything. It's when your number that you have to distribute is negative that it like screws stuff up. And so it's one of those things, it's just easier to never distribute. That way you don't have to remember when you can and when you can't. Like if you just never do it, you're good. So then I end up with the absolute value of x minus 7 is greater than or equal to 3. So what do I do now? Okay, split it up into 2 equations. What's my first one? X minus 7 is greater than or equal to 3. And what's my second one? Less than or equal to negative 3. Okay, work that out, please. So, you should have ended up with 2 things. X is greater than or equal to 10, and x is less than or equal to 4. Okay, so pay attention to what they say. So, we start with x is greater than or equal to 10. So, am I going to have an open circle or a closed circle at 10? Closed, okay. And it says it wants x's that are greater than or equal to that. Which direction is greater? Right. To the right. So, this time, your line is going to be going out to the right. They are not going to meet when we draw them. Okay, when we draw our two lines, they're not going to meet. So our other one said that x was greater than or less than or equal to 4. So where's that going to start at? At positive 4. Open or close circle. Okay, and then I'm going to draw a line which way if it wants x's that are less than or equal to the left.
So they don't have to.
They do not have to meet. So let's talk about what this means. Okay, so I would like for you to pick a number in between in this middle area here that we didn't fill in.
7. 6 is actually the number line.
We'll do 6. Okay. All right. So what I'm going to do is over here, I'm going to plug that 6 in. So my problem says 3 times the absolute value. Instead of x, we're going to put what number? What do we pick? 6. So 3 times the absolute value of 6 minus 7 is greater than or equal to 9. Okay. So if we work this out algebraically, okay, what is 6 minus 7? So negative 1. So I really have 3 times the absolute value of negative 1 is greater than or equal to 9. What's the absolute value of negative 1? Positive 1. So then I have 3 times the absolute value, or sorry, not anymore. Just 3 times positive 1 is greater than or equal to 9. What is 3 times positive 1? Is 3 greater than or equal to 9? Okay, that is why the numbers in the middle are not our solution. That is why we did not connect the dots in the middle, because those numbers in the middle in between 4 and 10, if we plug them in, they're not going to work. They're not going to give us something that's true. So what's going to happen then if I were to pick a number that's either less than 4 or greater than 10? What should happen? It should be true, okay? So let's pick 0. Let's do that one. We're going to do one on both sides. So let's start with 0, okay? So my inequality, or my absolute value inequality, says 3 times x, but instead of x, we're going to put 0. Minus 7 is greater than or equal to 9. So just doing the math, 0 minus 7 is going to be negative 7. So 3 times the absolute value of negative 7 is greater than or equal to 9. What is the absolute value of negative 7? Positive 7. So we get 3 times 7 is greater than or equal to 9. What is 3 times 7?
21.
Is 21 greater than or equal to 9? So that one worked out to be something that was true. Okay, let's pick another number that's in the yellow section. So what's a number in the yellow? 12. Okay, so again, I'm going to do the same process, but this time, instead of plugging in 0 or plugging in 6, I'm going to plug in 12. So 3 times the absolute value of 12 minus 7 should be greater than or equal to 9. What is 12 minus 7?
5.
5. So we end up with 3 times 5, or the absolute value of 5 is greater than or equal to 9. What is the absolute value of 5?
What?
The absolute value of 5 is 5. So 3 times 5 is
15.
So you end up with 15 is greater than or equal to 9.
Yes.
So because 15 is greater than or equal to 9, this inequality is true. And that is, again, why everything to the left of 10, everything to the right of 10 is going to be a solution. So for problem 10, you should have ended up with 2. X is less than 1. And x is greater than negative 4. So when we connected them, when we drew them out, it was a connection this time. Okay? All right. When do you think, what kind of inequalities are going to give you no solution?
When they're both on the same way.
Okay, so it has something to do with when they're negatives. Let's say I have like x, absolute value of x minus 4, and then it has something to do with negative 5.
Oh, when it says less than or equal to.
It cannot be less than or equal to negative 5. Because think about absolute value. When you take something out of the, you put in the absolute value symbol, it's always going to come out what? Positive. Positive numbers can never be less than negative numbers. Okay? Ever. Hold on. So just to kind of give you like a generic thing, if you have the absolute value of something, it can never be less than a negative number. Less than or equal to. If you have this, it is automatically no solution. Don't I like my something? Isn't that pretty?
Oh, yeah.
Okay, so here's the next question. Can it be, hold on, if you had the absolute value of something is greater than like a negative number?
No, you're not, because that's a negative. You can't have a negative.
No. Can the absolute value of something be greater than something negative?
Yes.
Okay.
It can't be greater than or equal
Because it could be greater than or greater than or equal to. It doesn't matter. The equal to part doesn't change anything. Oh, you're right. It couldn't be equal to. Sorry. No, it could be. Because you could have, hold on. You could have that symbol. You could have that symbol. That symbol doesn't necessarily mean it has to be equal to. It's saying it could be greater than or equal to. Okay? I'm not saying it has to be. Just trust me. I know that it cannot actually be equal to. But that symbol doesn't mean that it has to be equal to. That symbol means there is a possibility. And I understand that it cannot. But that does not mean that this problem is an invalid problem. Because what you're saying is that this graph is either greater than or equal to that number. It will never be equal to that number. Ever. But it can be greater than. You can have that symbol. I promise. Give me a second. I'm going to graph it. Okay. So what about this? Because when you take the absolute value, what always happens? It always turns out positive, right?
And it can be greater, and it's always going to be greater than.
It's always going to be greater than a negative number. So what does that mean?
No solution. No.
What does that mean?
What does what mean?
There's infinite solutions. Because it'll always be. Whoa. So smart.
That means that there are infinite
Because if it's
solutions.
a positive number, it's never going to be a negative number. It's never going to be less than a negative number if it's always positive.
Exactly. Okay, so